Very much. Thank you very much. Good morning, everybody. I'm very pleased to give you a few numbers this morning, very short. I want to address 3 points. Where are we? Where are we heading? And why this is dangerous. Where are we? Well, we're looking at this curve here, the most famous curve, the most important curve when we talk about climate change. It is the CO2 concentration in the atmosphere measured in high precision since 1958. And essentially, it's a message of our dumping a waste into the atmosphere for free. You see, it's increasing constantly, monotonously, and the cause is the burning of fossil fuels, as we all know. Now, for a bigger context, the question arises, is this unprecedented? Is this something unusual? And yes, it is. Our research at the University of Berne in the context of international projects has shown that this concentration that we measure in, now you don't see it, in 2023 is actually unprecedented in the last 800,000 years. You see here the data of the last 800,000 years of carbon dioxide concentration. It has never been constant, that's true, but today it's 35% higher than ever in the last 800,000 years. And the rapidity of increase is about 200 times faster than any natural increase that we measure over that time period. This is a fact. It's not indirect data. It's measured concentrations of carbon dioxide in old air, and that old air we're finding in the ice cores of Antarctica. Now that leads to a warming, as we all know. Here are the temperature data based on millions of data points collected all over the world since 1850, quality checked by independent and competing research organizations, and depicted in a way that is a little bit different from the usual. It's the warming stripes that you all know from 1850 to 2022, with the warmest years since about 1950, since the worldwide explosion of the use of fossil fuels, of coal, oil, and gas, and deforestation. A more detailed picture arises here. These are monthly mean global temperatures since 1980. And you see, apart from the warming that we would expect already on the previous slide, you also see these record summers that the world has experienced in ever higher frequency. 2023 really stands out. It's the last bar on this graph on the far right. That's where we are today. We are in an unprecedented time of warming, and I usually call it by now heating. This heating is not only in the atmosphere, and we know the atmosphere can change temperature very quickly. You've seen it yesterday and this morning. We're close to 0 degrees. So it's very difficult for people to perceive urgency when you just look at atmospheric temperature. Here instead, the scientists have collected data of sea surface temperature or ocean surface temperature. That is the warming of water. As you all know, the warming of water requires a lot of energy. And what you see here in this picture, it's a seasonal cycle from January to December for the last 40 years. And you see here the mean from 1982 to 2011. That's the normal seasonal cycle of mean ocean temperature from 60 degrees south to 60 degrees north. A huge mass of water where we take the temperature. 2022 is this curve, and 2023 is this curve. For some of you who know some numbers, you could now calculate the amount of energy that you would need to increase the sea surface temperature globally by about half a degree. It's an enormous amount of energy, and that energy ultimately comes from the heat trapping greenhouse gases in the atmosphere. Where are we heading? Well, I won't show you the temperature scenarios. You know them, you've seen them many times. Where we are heading depends on our decisions today. And here I show you the emissions of carbon dioxide equivalents in billion tons per year. The historical evolution you see from 1990 to 2022 in the black curve. It's an increasing curve, very resilient. The financial crisis you see there as a little dip, and then the corona crisis you see as a little dip, but this is probably the most resilient system that you can see. It's just going back to normal, to business as usual, when some short-term crises are over. But in order to head off the climate crisis, this green curve is actually needed. And the green curve is very different from the blue plume that you see in this curve, which is the resulting emissions from the current policies, which will bring us well over 2 degrees Celsius, 2 degrees being the upper limit of the Paris Agreement. So current policies are totally insufficient. In fact, we will fail Paris if we continue with current policies. So there is a policy gap or a implementation gap indicated by these reddish arrows. We should go down with the emissions almost immediately to about half the emissions by 2030. We're all familiar with that number as well. And you see here, this target gap 2030 is about half of the global emissions today. It's a huge amount of emissions that we need to reduce. There's also an implementation gap that is even a little bit higher. You see the pledges and targets that are done within the UN Framework Convention on Climate Change would bring us down here. That's if every party would actually stick to the pledges and the targets. And that would be needed, this green one, for 1.5. The more ambitious target, remember that target came into the Paris negotiations because of the small island and low-lying states that are immediately threatened by sea level rise. Now, extreme events are particularly relevant for the well-being or the ill-being of populations. Just one example here that is very familiar to us is the heating of the Mediterranean and the neighboring countries and regions. You see here in June 2022, but 23 was very similar, unprecedented heat in the ocean. Now, this is difficult for communities, but it's also difficult for the marine life and the ecosystems on which our food production depends. Now, in IPCC, in the last assessment report, this window to the future that we've seen in 2022 and 2023 is actually projected to different warming levels. And you see here typical heat wave, so-called 50-year events. That means an event that occurs only once in 50 years statistically. That is the past. We are already in a world where this has become a 1 in 10 years time. That's the present 1 degree Celsius warming. But if we are heading to 2 degrees, it will be about 14 times in 50 years. If we are heading to 4 degrees, it will be about new normal, almost 40 times in 50 years. That is what's happening with climate change. It's not a slow increase in average temperature. That it is also, but what is most challenging are the statistical changes of extreme events. And here I'm just giving you the example of heat waves. Why is this dangerous? Dangerous, remember Article 2 of the Framework Convention on Climate Change, which has been in force since 1994, says we need to act to prevent dangerous anthropogenic interference with the climate system. Here is one danger. It's associated with the heat waves. That is the so-called wet bulb temperature. And what you see here is the number of days of this temperature increasing 31 degrees. It's a combination of humidity and temperature. It's that climate condition that really makes you feel bad and threatens, in fact, your health. It can actually be life-threatening if you perform labor outside unprotected under such high temperatures. And what you see here in the color bar is the number of days that this wet bulb temperature assumes dangerous levels. And you see where these regions are. They are in the tropics and extratropics. They are in India with days already at the warming level of 1.5 degrees. That's within about the next decade of exceeding 100 days per year. So a third of the year, climate conditions will be almost unbearable. With a warming level of 3 degrees, however, you see that these regions extend and therefore affect many more millions of people. And also the colors intensify, indicating that climates are experienced that are unprecedented in many areas of the world. That means also adaptation challenges, and in many regions, adaptation will not be possible. A second dangerous element is the change of the water cycle, and I've titled that as a resource. Of course, it's a resource for humans and ecosystems. If the water cycle changes either too much, too little, or in the wrong time, then adaptation must take place, and that adaptation has implications. You see here of the latest assessment from 2021, the IPCC Atlas I extracted for the warming level of 1.5 degrees Celsius global warming. You see some brownish areas where there will be percent-wise less precipitation in the tropics, essentially a bit more, and in the high latitudes. It really gets dangerous at 3 degrees Celsius warming levels. And that is, remember, would be what results at the higher end with the present policies. You see here strong increases of precipitation in the tropics. You may ignore actually the Saharan area because that has today almost zero precipitation. And in this analysis where you look at the percent change, the percent change is large, but that doesn't mean it's getting really wet there. So a large fraction of zero is still zero. What is more challenging, of course, are the brown areas where you see drying. The Mediterranean comes to mind, Australia comes to mind, and the extratropical regions in the southern hemisphere will be particularly challenged. A third dangerous effect concerns sea level rise. That's on the more long-term time scale, dangerous changes of sea level rise here on this very recently compiled map for a warming level of 2 and 4 degrees Celsius. The red circles indicate the amount in millions of people, and we zoom into this map here, Southeastern Asia, with the warming level of 2 degrees. These are the red circles. You see essentially all the megacities are affected. With 4 degrees, it's really the entire region that is challenged by sea level rise. And it's not just the inundation, it's much earlier, starting by water intrusion of undrinkable salt water that challenges these communities. And finally, tipping point, something that is highly discussed and debated in the climate science. There are by now a whole catalog of tipping points. These are large-scale surprises in the climate system that actually are disruptive. I just mentioned 2 of them. The Atlantic meridional overturning circulation, which is essentially the heat pump for the northern hemisphere, essentially around the Atlantic, that could collapse. Some data already indicate a reduction, but this is a controversial topic which requires more attention. But what I'm more concerned is actually regional water patterns and weather patterns, like the Indian summer monsoon. If you imagine that this shifts by a few weeks or loses intensity, the effects will be devastating. And in closing, I would like to quote here a statement out of the technical summary of the 6th assessment report, Working Group 2, that looks at impacts and vulnerability. And in that summary for policymakers, it said, under all global warming levels, some regions that are densely populated will become unsafe or uninhabitable. That's the finding of the scientists. It's the consensus of the scientific community. And as through the IPCC process, it's also endorsed by all governments of the world. Thank you very much.
Thank you, Thomas Stocker. You can just stay with me for a minute if you like.
Sure.
We have time for one or maybe two short questions from the audience. We have microphones in the room, so if somebody would like to ask a question, just raise your hand. Don't be shy. It's like in a ball, you know, when two begin to dance, then the others join. So
we should dance now?
We could. I mean, I don't know if you.
No,
if
I'm not a good dancer.
No, you're not. Okay,
no.
I am a good dancer.
Oh, okay.
Yes. So.
So go ahead.
No, it's okay. It's not in the contract. So everybody, anybody? I have a question, Thomas Stocker. You have a very, I mean, we have seen a very grim prognostic. And sometimes I wonder, you know, when I listen to you, I also read a lot of articles, and you are very, I mean, I hear a lot from your work. And sometimes I wonder, how does a scientific person go on with his scientific material when it is so clear what is going on and it's so hard to get the message through so that people really are aware of what's going on? Well, how do you manage?
It's frustration, but frustration is also a challenge to really try to convince people. And you know, the basic facts were around already 50 years ago. Mm-hmm. My predecessor, Hans Oeschger, has been a warner and has been a communicator on this very same topic already 50 years ago. I've been doing this for 30 years now, but I must say the progress is slow, but where we stand today is very different from then, although I must say the emissions haven't gone back. Mm-hmm. And that's where we need to be heading, and that's the constant challenge we have and the motivation to really convince people in Switzerland, in Europe, but also in the world, foremost, of course, the industrialized countries, that it's now time to reduce and take that as an opportunity for economy to actually make that transformation while preserving resources. It's really that difficult challenge and task to preserve resources. We've heard it. They are finite. There's probably this is the one single consensus we all have. We know they are finite, but we are not acting accordingly.
We will talk about also how, you know, exactly the growth myth has maybe to change. We will talk about this this afternoon. Last chance for there is a question, please. You can take the microphone and please introduce yourself shortly so we know who is asking the question.
My name is Valentina Maggiulli and I'm working for SwissAid. I have a question. I mean, it's on a global level where we need to do more advocacy, obviously, on all players, but what would you recommend for the Swiss government?
Well, I would first of all turn that recommendation back to the Swiss people and those who actually cast a vote. In fact, who hasn't voted by now has still an opportunity.
Exactly.
And it's voting those people into parliament, that's the first point, that actually have a priority in these topics that we are just discussing, and you can all think for yourself who that might be. That's point number one. Point number two, Switzerland needs to actually lead as an example. We are one of the richest countries with a lot of brain power, with a lot of money, and we could actually lead that transformation and at the same time show the world it's doable it's doable, and there's no harm to make business out of new products that you need. But we're still far away from there. We're still essentially on a business model that gives hosts organizations that actually don't preserve resources, if you know what I mean, but they squander resources.
Will you stay here a bit? So will people be able to ask you some more questions during the break, maybe? Okay.
Until
Thank
the
you.
break.
Thank you,
And in
Thomas
the break.
Strocker.
Thank you very
for
much.
the dance.